They also understand your WhatsApp. In my comments section, start చేసినాక మీరు వచ్చేస్తారు. Yeah. So, good evening, everyone. Before we start off, let me introduce myself as Ravi, and today we are going to talk about motion in a straight line. So that is the topic that we will see and cover today. So before we start off, a couple of hygiene factors or couple of expectations from my side is that you are concentrating and you're going through the lecture thoroughly in a place where you are able to concentrate and you are able to take notes of whatever we discuss. And if you have any questions or queries, etc., you can put it in the comments box, and we will definitely go through once we are done with the class. Now, the second most important thing is we have started these classes online. So the idea is that you see our way of teaching, you believe in our methodology, and then you focus more on the courses, etc., and all, and come to us and join the Spark Academy. Okay. Now, briefly to start off with, if you remember in your 8th class, 9th class, and 10th class, you must have definitely dealt with few parameters like, let me write it, a few parameters like say S, which represents your distance and displacement. Either way, displacement. V would be your speed and velocity. Okay, and the next one would be A, which is acceleration. Couple of things. In couple of cases, you must have heard about displacement. Okay? So this is the major portions or major terms or the terms you must have come across or you've heard about it, and you must have gone through all the problems pertaining to it. Now, coming to the questions, whether it be it JEE, NEET, or EAMCET, etc., what we describe motion in a single dimension. Okay, you must have referred the same thing as kinematics in your ninth and 10th classes, 8th or ninth or 10th classes, kinematics. Okay, so this is what we are going to see. Now, most importantly, okay, so when we start off with this thing, so let's say I am talking about kinematics. Okay, while I am talking about kinematics, this is, if you remember, in your potential energy and kinetic energy, etc. Kinetic energy refers to something that is in motion. Similarly, this is also in motion. Okay, this is also in motion, and matrix is nothing but your motion. Okay, clear? So, what we are going to deal is the terms, the mathematics, or the physics, however you call it, whether you call it maths or physics or interchangeably you can use. You are going to deal the phenomenon between all the objects that are in motion. Okay, all that are in motion in single dimension. In single dimension. Now, in single dimension, what we generally call it a straight line, or your all the cases of ball thrown upwards, coming down, etc. Your 2D cases, that is all your single dimension. Okay, motion in straight line. Okay, now in your two-dimensional part, you would definitely come across the circular motions, the projectiles. Okay, you have an axis here, a ball traveling, or you've thrown a ball, the projectile motion. That is one case of it. The second is a circular motion. Okay, ball starts here, or you move it here, or you move around a circular path of a racing, etc., and that is a circular motion. So this is all 2D. Okay, so what we are going to deal is completely on the kinematics part, which is in a straight line motion or a one dimensional motion. Okay, now the most important thing is there are 4 5 terms which you will have to, which you already come across, and now which you will also see once again. Okay, so the most important thing is in terms of the parameters or the terms that you come across. One would be your distance, S, or displacement, like I told you. Second, V is your speed or velocity. Okay. Third is your acceleration or deceleration for a second. Let's assume acceleration or deceleration. Next most important thing is your time. Okay, these are the 4 5 parameters that you're going to deal with in your entire kinematics topic. Okay, obviously all the questions will be centered around these parameters only. Say example, if you have distance, velocity, they might have asked you for time or acceleration, etc. If you have velocity and time, they might ask you acceleration. Similarly, so the idea is you know all these concepts. You have in the given questions, you are given couple of parameters like distance, velocity, acceleration, time. You're supposed to find out any three. They will give you the fourth one. You are going to find out. Now there might be different types of distances, different types of speeds, etc., which we will see. But the central idea is these are the predominant four parameters that you're going to see, and this is how you're based on your formulas, be it with respect to all the relations that you have learned. Based on the formulas, you are going to find out the fourth dimension or the fourth parameter, which is missing, which is the missing piece in this entire question. Okay, it's as simple as that. Out of all these four parameters, there will be three. You are supposed to find out the four. As simple as that. Okay. Now let's start off. Let's start. Okay. Let's start off with the first one, first concept. Let's start off with, okay, distance or displacement. Now you all know what is the difference between a distance and displacement. For your reference, let me refresh or recap it for your reference. Displacement is nothing but a vector. Okay. Now, and one more thing, let me tell you. In all your physical quantities or your physics, etc., please try to correlate all the chapters that you're reading. Say example, when you start off, ideally you're going to start off with units and dimensions, then move to vectors, then move to motion in single dimension, then your two dimensional, then you move to dynamics, which is your forces, etc. Then you go to the circular motions, potential energies, kinetic energies, etc. So even in second year, once you go to current, electricity, magnetism, etc., all these topics, remember a couple of things. Your fundamentals of units and dimensions, your vectors, etc., do not change. Okay, fundamentals of units and dimensions or vector concepts, etc., do not change wherever you go. As long as you are reading physics, the concepts remain same, the formulas, the applications remain same. Okay, so I am assuming you are mature enough and you are, you know, the basics of all this, so that we start off directly to this distance and displacement. Okay, now, so as I've told you, so distance is a scalar while displacement is a vector. Correct? Noted. Most obvious thing. Now second most important thing, how do you define displacement? Is nothing but shortest distance. Okay, it's the shortest distance. Okay, it's the shortest distance. Now example, I have a point A. Let's say I have a point A and I have a point B here. Let's say I have a point A and I have a point B here. There are multiple ways I can reach this A. I mean, if I'm traveling from A to B, there are multiple ways. Okay, I can directly travel like this. I can travel like this. I can go like this. I can come like this directly straight A to B, or else I can go like this. However you call it, whichever path you take, whichever, there are n number of ways to reach B. But all of this, okay, remember, let's assume, say I'm calling this path 1, this is path 2, this is path 3, this is path 4, this is path 5. Okay, all of this constitute for your distance. All of this constitute for your distance. Okay, all of this are your distance, because what is distance? It is nothing but your travel from A to B, your journey. That is nothing but your distance. Correct? But whereas the difference comes in the displacement. Okay, you are well aware of this. The difference comes in the displacement. Now, how do you define displacement? It is nothing but the shortest distance. Now, in all of these five paths, 1, 2, 3, 4, and 5, which of the following is the shortest? It is from A to B. It is from A to B. This is the shortest path. So, this is your displacement, while 1, 2, 4, and 5 continue to remain distances. Okay, what is the distance you have traveled from A to B? If you have taken path A, it might be 50 kilometers. Okay, it is still a distance. It is still a distance. If you have traveled from 1 to 2, sorry, A to B in path 2, it might be 35 kilometers. Okay, but if you have traveled from A to B, it might be directly, say, 15 kilometers. Fourth might be 20 kilometers. Fifth again might be 25 kilometers. Okay, all of this are distances. All of these are distances. but the displacement is 15 because that is the shortest distance that you've traveled, and that is your displacement. Now, in all of your questions, if you've seen, there are multiple scenarios that you can do. Okay, let's see a couple of them. Say, example, you have a circuit. Okay, you have a circuit. You are aware of all these things. I start from here, and again I come back to this point. Okay, what is my displacement? What is my displacement? Displacement is zero. Why? Because I have, from the point where I have moved, I come back. I have come back to the same point again. From the point where I have moved, if I have started from A, I have come back to A again. Okay, I have come back to A again. So that means my displacement is zero. But whereas, what is your distance? Your distance is nothing but circumference of the circle. So if the radius of this is R, so my distance is nothing but 2 pi R. Correct? The distance is nothing but 2 pi R, because that is what I have traveled through the entire journey from A to A. That is the distance I have traveled. Now from this, can I conclude from the above two examples or from the above two scenarios? Can I conclude that irrespective of the situation, you are talking about a concept where distance is always greater than or equal to displacement. Okay? There can never be a scenario where your displacement is greater than distance. Why? Because you've seen in the previous cases, displacement is the shortest distance that you take. Correct? It is the shortest path that you take. There cannot be a greater or a lengthier path than that. And if that is lengthier, then you are not going to call it a distance. Clear? Understood on this? So distance is always greater than or equal to displacement. Now, in all your cases, there are multiple scenarios that we discuss. Say example, couple of cases. Let's say you have a square. Okay, you have a square. Okay, now I travel from along the line of the square. I travel, and again I come back. Again I come back. Okay, I travel along the length of the square, and again I come back. Okay, my displacement here is zero because I've started from A and I've come back to. So this my displacement is zero. Whereas my distance, what will be my distance? My distance is nothing but, if the side of the square is, let's assume it is D. The side of the square is D. 1, 2, 3, 4. 4D is my distance. Correct? Because I have traveled along this path. 4D. As simple. Similarly, let's assume I have a square or I have a circle. Let's assume I have a circle. Now, if I am traveling from A to B, okay, if I am traveling from A to B, this is my distance. That is, this is my distance. Yeah, what is the circumference of the circle? 2 pi r. I have traveled one fourth of it. Therefore, this is half one fourth. Therefore, it is pi r by 2 is my distance. So what is my displacement? That is going to be the shortest path. That is from A to B. A to B. A to B. This is my shortest path. Then how do I find this? How do I find this? Now I take this right angle triangle from the circle. This is my R. This is my R. Based on these two, I find the displacement. This is nothing but root 2R. R square plus R square under. So my displacement is R displacement. Okay. Okay. You can have multiple scenarios in multiple cases where they ask you the distance and the displacement. All you have to do is assume you're riding a bike and you're sitting on this. So from A to B, if you're covering, you're driving a bike from A to B, you've moved. This is the distance you've traveled, which is pi r by 2, because it is one fourth of the circumference. And if it is displacement, it is nothing but it is the shortest distance between A to B, okay, which is root 2. So similarly, if I extend the same logic to A and B, A and B. Now what will be the distance be? What will be the distance be? This is nothing but 2 pi r by 2, because I have traveled half the circle. Therefore, my distance is pi r. Correct? Similarly, what will be my displacement? If this is r, the shortest distance is r plus r, 2r. That is my displacement. Clear? Understood? Now, similarly, you can have multiple concepts. I can take any angle. In fact, I can take any angle. I can take any angle. Okay? It's not necessary that I'll have to give one fourth only. Let's assume this is my circle. Okay, I've traveled from A to B. Okay? I've traveled from A to B. So this is going to be. Okay, like how you found out here, you're going to find out the shortest distance, assuming this is r, this is r. You're going to find out this is an angle given here. Okay, and there are multiple scenarios which we can. Now this is your two-dimensional motion. Similarly, if I go to three-dimensional motion, assume you have a cube. Okay, assume you have a cube. Assume you have a cube. Similar example. Assume this is point A. I have traveled from here to here, here, here. Okay. This is A. While my distance is nothing but A plus A, which is 3A. But my displacement is nothing but the diagonal of this. Clear? Similarly, in your cubes or your any other shapes, whatever you take, similar concept. You are supposed to find out the distance with respect to the distance. Okay. In all these cases, that is how you are going to do. Say example, if you have seen the vectors concept. Okay, if you've seen the vectors concept or you know the directions, you always talk about your directions being this is east, west, north, and south. Correct? Not well, correct. Now, if you remember a couple of cases where you must have seen there is a person who travels 5 meters towards east in all the vector concepts, then 10 meters towards north, okay, and assume he stops here. Your displacement is not 5 plus 5, but your displacement is nothing but the shortest distance, which is 5 root 2, which is 5 root. You're taking this because you're assuming this angle is 40 because it's a right angle triangle, correct? But whereas if you see the distance, it is nothing but this 5 plus this 5, both put together. Distance is 5 plus 5, whereas the displacement is 5 root 2, which is the shortest in all your vector concepts. So similarly, if I am traveling a direction in east, okay, you say I am traveling from A, I am traveling 5 meters towards east, and okay, and in the similar length, if you're coming back again, okay, if you're coming back again by 5 meters, okay, your displacement is 0. Your displacement for this case is 0. Okay, but the distance is 5 plus 5 10. Understood? I hope you're understanding. Like I've told you, distance is nothing but the entire path that you traveled, whereas displacement is your shortest distance. Clear? On different scenarios, different situations that you can come across with respect to distance and displacement. Okay. This is one of the things that we want to discuss, and you already know about all these things, and consider this as a refresher session. Okay, and one more thing, while I'm talking about in all your exams, be it NEET, JEE, or IIT, this topic of kinematics or this topic of motion in a straight line is what I call in my parlance a boundary ball. Okay. Example: if you've known cricket, if you've watched cricket, there are few boundary balls which a bowler gives. Example: full toss or a slow ball, etc., where you are supposed to definitely hit this for a 4 or a 6. Okay, that's supposed to be boundary ball. Okay. Similarly, this concept or this topic, motion in a straight line, is supposed to be a boundary ball concept. That means, given a question paper, you are supposed to find out quickly, scan through the question paper and find out which are the questions pertaining to this topic and answer them immediately. You're supposed to answer them, go through the topic, go through the questions which whenever you get an exam paper, and the first point and first questions you are supposed to scan through, or you're going to attempt should be your motion statement, because all these are boundary questions. Easy to understand, simple logic, simple formulas, and nothing complicated scenarios, etc. And you can easily get the correct answer within few quick seconds. You understand the question, you understand the scenario, your half of the job is done there. If you understand the scenario, if you understand the graphs correctly, half of your job is done there. It's just a matter of putting pen on the paper and finding out the answer while using the formulas. That's it. So in my parlance, I will call this as boundary boundary topic. Okay, like I've told you, boundary topic is nothing but you are definitely supposed to hit a 4 or 6 in this topic. That means you are supposed to get a sure short answer within the first 30 seconds or 45 seconds of looking at this question. Okay, understood? Now let's move on. Now let's move on. Now the second most important thing that you've gone through, or now that we have seen distance and displacement, we will solve few problems tomorrow. We will solve few problems tomorrow. Now today we will see the concept. Now between v, that is velocity, it can be nothing but speed or speed or velocity. Speed or velocity. A similar differentiation, like how we have done distance and displacement, a similar differentiation here also exists. Velocity is nothing but vector. Velocity is nothing but vector. Speed is nothing but scale. Correct? And the formula is nothing but the velocity formula is nothing but, if you're talking about velocity, is nothing but total displacement by total time. Okay? Whereas if it is speed, it is total distance by total time. Okay? Simple differentiation. Total distance by total time is your speed. Total displacement by total time is your velocity. Clear? Understood? So, example, in the previous case where we have seen where there is a square or a circle. So, let's say this is your square. Okay. So, starting from point A. Now, if you've traveled this, say in 5 seconds, or say in 10 seconds, okay, or 10 seconds, okay, and the side of the square is nothing but 10 meters, okay. What is your distance that I've told you? Distance is nothing but total journey, okay. 10 plus 10 plus 10 plus 10, which is 40. So your total distance is 40, total time is 10 seconds. So therefore your speed, remember again, speed is 4 meters per second. The units all remain same. The units between speed and velocity, or units between distance and displacement, is all same. There you have meters, here you have meters per second, same units, okay. But the concept changes while coming to the velocity, okay. Now what is your velocity? Total displacement by total time. What is your displacement? Zero, because why? You've come back to the same position where you started. So this is, displacement is zero, therefore your velocity here is zero. Clear? Understood? Okay. Now I'm not going to discuss the formulas that you've already seen in your ninth and 10th kinematics, where you say final velocity is nothing but u plus at. Then you have distance is nothing but ut plus half at square, so on and so forth. Okay. I'm not going to discuss these formulas because this is understood and you're thorough with all these things. So we are going to talk about much more other concepts like average velocity, instantaneous velocity, which is definitely sure short question in one of your papers. Okay, they might give you different scenarios and they will ask you to find out the average velocity or average speed or instantaneous velocity or instantaneous speed, whichever is the case. Okay, so I am assuming you are thorough of all these initial velocity concepts, final velocity, acceleration. So now we will move on to this further topic. Okay, now that you have understood what is speed and what is velocity. Speed is nothing but total distance by total time. Velocity is nothing but total displacement by total time. Do not get confused. Speed is distance, velocity is displacement. Scalar being scalar. Okay, while you divide uh, distance with time, you get a speed which is scalar, distance is scalar, therefore scalar is equivalent to scalar. Okay, so that is how also you can remember. Displacement being a vector, if you divide by time, you get a vector which is velocity. Okay, and one more simple conversion, your kilometer per hour, if you have to convert into meters per second, always multiply by 5 by 2. Yeah, simple rule. Kilometer is higher than meter, that is why you are dividing with a bigger number, dividing with a bigger number. If it's the converse, that is, if you have to convert meter per second into kilometer, you are supposed to do by 8, as simple. Okay, gives you meter. Okay, simple rules, simple concepts. Ensure that you do not make mistakes in the simple things. Okay, you do not make mistakes in the simple things. Okay, these are all, like I've told you, boundary balls or boundary concepts where you are supposed to answer 100% thoroughly with within the shortest possible time. This is where you answer the questions quickly, get your confidence in the exam paper, move to difficult questions. Okay, understood? So now that we have seen distance and displacement, now let's talk about something. If you've already gone through it, let's talk about couple of things like average. In all your maths concepts, if you've seen, you have, let's assume you have five numbers. Okay, you have one, two, three, four, five. Okay, five numbers. If I ask you to find out the average, what would you do? You would definitely do 1 plus 2 plus 3 plus 4 plus 5 divided by 5, because you are finding out the average, you are taking the summation of this divided by. Similar concept here as well. You have something called average velocity, which is represented by delta v, which is total velocity by total time. Okay, similarly, and now you have a new concept called instantaneous velocity. Instantaneous velocity is nothing but velocity at that particular instant. At that particular instant, from the name itself you can derive. It is instantaneous velocity is nothing but velocity at that particular instant. Now, example, let's say I am traveling from Narayanguda to Secunderabad. Okay, from Narayanguda to Secunderabad. Let's assume I am traveling. Okay, now between Narayanguda to Secunderabad. Okay, if you ask me what was my instantaneous velocity at say Himayatnagar. Okay, but let's assume I am traveling to RTC Crossroads. Okay, let's say the question is what was my instantaneous velocity at RTC Crossroads. Okay, the question what you are asking is you are interested in knowing. So let's say this is my path. So let's say this is my path from Narayanguda to Secunderabad. You are interested to know my velocity at this point of RTC Crossroads only. Okay, at this instant of RTC Crossroads, what is my velocity? Okay, what is my velocity? That is your instantaneous velocity. Okay, how we will get the instantaneous velocity, how are these derived, etc., that we will see slowly. Okay, but you've understood the difference. Similarly, in similar vein, you have instantaneous speed and instant and average speed as well. Average speed is nothing but, for all your parlance, I mean, if you are considering v as velocity, I will just say delta s by delta t is nothing but average. Okay, okay, clear? Now, in all of this, you have multiple questions, multiple scenarios coming in. Say example, if you have seen couple of papers of train questions, your boat questions, your speed questions, etc., there are multiple scenarios, but always remember the concept you mentioned. you know the fundamental concept of distance is nothing but speed by time. Okay, speed by time, displacement is nothing but velocity by time. Okay, you are deriving all this from here, be it your speedboat questions or train speed questions, etc., or average velocities or average speed questions, etc. Now let's say from here let's say from here, couple of examples. Let's say you're traveling from A to B. Okay, you're traveling from A to B, you have multiple scenarios. Say example, you travel from A to B, you travel with the velocity of v1. From B to A, you travel with the velocity of v2. Okay, they will ask you what is the average velocity for this entire journey. Okay, average velocity for this entire journey. Understand, any given average velocity or this thing, the simple concept is they are asking you to find the total displacement by total time. Okay, total displacement by total time. Now let's assume the distance between A and B. For parlance, when I'm saying distance between A and B, okay, average. No, you can ask me, sir, if I'm traveling from A to B and again coming from B to A, won't my average velocity be zero? If you are taking for the entire journey, yes, it is definitely zero. Now that is why between speed and velocity, we keep changing it interchangeably. Okay, if they tell you distance, they will talk about speed. Okay, which is v. If it is displacement, then this becomes velocity, as simple as that. Now, okay, now total distance traveled is what? From A to B, if I'm assuming my distance between A to B is d. A to B is d, so it is All I'm supposed to find out is total distance, correct? Which is nothing but from A to B is V. Again, B to A is nothing but D. Correct? Correct. Now, what is my time from A to B? Total time taken. Okay. Total time. What is that I know? What is that I know? I know the speed traveled between A to B. It is nothing but B by V1. Okay. Plus, what is the time taken traveled from B to A? Obviously, the velocity is different. The time taken will be different. Therefore, it is nothing but B by D by V2. Okay. Okay. While distance is nothing but speed by time. Time is nothing but distance by speed. Correct? Correct? As simple as that. Clear? So from this you will find out average speed. Okay. You can have multiple scenarios in this. So example, in similar length. Let's assume they will tell you A to B half the distance. Half the distance, my velocity is V1. Another half the velocity is V2. Okay, we have to find out the average velocity. It is nothing but, let's assume total distance is d or total displacement is d. Total displacement is d. Time is nothing but d by 2 by v1 plus d by 2 by v2. Why did I take d by 2? Because half half of the distance traveled is with velocity v1, while the other half is v2. Clear? Now you can have n number of parts. Say example, I have three parts. Say example, I have total displacement or distance traveled is d. Okay, and for first one third of it I have v1. For the second one third I have v2. For the third one third I have v3. Clear? Understood? Now, how do I do this thing? Same thing. Total distance or total displacement by total time. My total displacement, that is from A to B. A to B is nothing but D. Total time. Total time taken is D by 3. D by 3 by V1 for this part. Let's assume T1, T2 and T3 are the times taken. So my total time is T1 plus T2 plus T3. As simple as that. Okay. So but what is T1? D by 3 by V1. Okay. D by 3 by V1. Okay. Plus D by 3 by V2 plus D by 3 by V2. Okay. As simple as that. Okay. Total distance by total time. Okay. In all these things, you would be given either V1, T1 or distance. You can have multiple scenarios, multiple cases, etc. All you have to do is check out which is the formula and which is the concept that you are, which is the parameter that you are supposed to find out. Okay, which is the parameter you are supposed to find out. Okay, as simple as that. Okay. Clear? Understood? Now you can have multiple equations, multiple scenarios where they'll ask you. Say example, you can have trains and similarly, like how we have said, times are. I mean, the distance is one third. You can have wherein time taken for this with a constant velocity, it takes half of the time, and the second thing takes another half of the time. Okay, you can have multiple concepts, multiple scenarios. Okay, now. Okay. Now we have seen average velocities. Instantaneous will slightly come to that. Will slightly come to that. Will slightly come to that. Okay. Now the next concept, if you are aware of it, is nothing but A or smaller. It is nothing but acceleration. It is nothing but change in velocity. Change in velocity by change in time. Okay. Change in velocity by change in time. Clear? Understood? So based on this, we will discuss if you've seen like in all your 10th class, maybe you would have definitely encountered there were a couple of graph questions which they would have given you between distance and time graph, velocity and time graphs, etc. Okay, that we will see slowly now. So remember this, acceleration is nothing but change in velocity by change in time. Your velocity is nothing but change in displacement by change in time. Okay, as simple as that. Now, like I've told you, the instantaneous velocity is nothing but you are supposed to find out the velocity at that instant. Okay, you are supposed to find out the velocity at that instant. Okay, instant is this. Okay. Now, if you've taken any graph, okay, let's say if you've seen a distance and a velocity graph. You know, the basic calculus, I'm assuming you would definitely know. This is where you start off with your calculus journey, your differential equations and your integral equations pertaining to physics. This is with this concept you're going to start off, because instantaneous velocity, when I'm talking about, it is done for, or you're calculating it for that particular instant. Okay, for that small instant. Say if you have traveled for say 100 seconds or 200 seconds, you are particularly asking about an instant. Say example, one instant of, or 15th second or a 30th second, where you want to know the velocity of that particular instant. Okay, that is why you tend to write instantaneous velocity is nothing but ds by dt. Okay, distance traveled, distance traveled in that instance. Okay, in that instant, by time take for that instance. Okay, for that instance. Okay, as simple as that. Okay, say example, I want to find out if my journey, total journey is worth 100 seconds. Okay, I have taken to travel from say Narayanguda to Secunderabad. Say I have taken 60 minutes. I am wanting to know in the 43rd instant or 43rd minute, at that instant, what what is my distance? What is my distance? Clear? Understood? So at that instant, it is nothing but ds by dt, where t is almost tending to 0, because you are asking about one particular small instant. That is why you have this differential of ds by dt. Okay, ds by dt. Okay, clear? Understood? So this is your instantaneous velocity, where you are supposed to do ds by dt. If I am talking about average velocity, it is nothing but, you would write nothing but, okay, sorry, delta s, delta s. Okay, total displacement by total. Okay, okay, this is nothing but your average. Clear on this? Clear? Now there are multiple, like I've told you, multiple graphs which you have already must have seen. Say example, example. Okay, let's say you have an equation. You have an equation. S is equal to, let's say, 2t square plus t. Okay. Now, if I ask you, let's assume this is one of the equations. Let's assume I ask you to find the instantaneous velocity. Instantaneous velocity at time t is equal to 2 seconds. Okay, 2 seconds. Now, what is instantaneous velocity in this particular instant of 2 seconds? I am asking you to find what is the velocity. Correct? Which is nothing but ds by dt, which is what? 2t square plus t, differential of this with respect to dt. Now a simple differential, you already know, this is nothing but, if I am talking about differentiation, this is nothing but 4t, because 2 into 2, 4 plus 1, and t differential is 1. So this is my instantaneous velocity at 2 seconds. At 2 seconds. At 2 seconds. What is my instantaneous velocity? It is nothing but 4 into 2 plus 1. 4 into 2 plus 1, which is nothing but 8 plus 1. 9 meters per second is my instantaneous velocity at that instant of t is equal to. Clear? Understood on this? Okay. When at the instant of 2 seconds, at the instant when time is 2 seconds, my instantaneous velocity is nothing but 9 meters per second. How did I get ds by dt? Okay. You have many other scenarios. Example, you can form your own question in this, because you can take 2t cube plus 2t square plus t plus 0 plus whatever you want. So if I'm talking about this and I ask you to find the instantaneous velocity when t is equal to 5 seconds. Okay, let's say t is equal to nothing but 5 seconds. All I have to do is differentiate this, because I am asking the instantaneous velocity, which is at a particular instant at 5 seconds. At 5 seconds, which is nothing but 6t square plus 4t plus 1 is my differential. Okay, my ds by dt is nothing but, because the differential of this is nothing but 6t square plus 4t plus 1. Okay, at what time I want the instant? At 5 seconds, correct? So if I'm talking about 5 seconds, is nothing but 6 into 5 square plus 4 into 5 plus 1. Okay, this is nothing but 6 into 25 plus 4 into 5 is 20 plus 1. Okay, 150 plus 20 plus 1, which is 170. So my instantaneous velocity, my instantaneous velocity at the instant when t is 5 is 1 second. Okay, clear, understood. Now you can have similarly. Let's say you don't have, you just have. Let's say you, let's say you have s is t square minus say 2t. Okay, and you are supposed to find out instant or say let's say you have 3D first 3D and you are supposed to find out at the instant t is 1 second. Okay, at the instant t is 1 second. Now it is nothing but ds by dt, correct, which is nothing but the differential of t square minus 3t, correct, differential of t square minus dt, which is nothing but 2t minus 3, it is nothing but 2t minus 3. Now, if I am talking about 1 second, if I am talking about 1 second, 2 into 1 minus 3, which is minus 1 meter per second. Now, you might ask me, 1 meter per second, you might ask me, how is it? It is minus 1. Okay, how is it minus 1? It is nothing but, it is nothing but from the reference of motion, from the reference of motion from where I am standing, it is going backwards. As simple as that. The magnitude of vector, or because velocity is vector, the magnitude is always 1, whereas the direction minus 1 indicates the direction. So from the reference of this point, say example, at this instant, if I am measuring from this point, let's assume I am standing here, let's assume I'm standing here, from my reference, okay, these are my eyes, okay, this object or uh, this body has an instantaneous velocity of minus 1 with respect to me. Let's assume if I've taken this as positive and this as negative, so from this point it is negative 1. Okay, from this point, because or from my point it is negative. Okay, you can take either ways. If you're starting from this point, from your point of view, this is minus 1 which is traveled in the other side. If it is plus 1, it is traveled in this side. As simple as that. Clear? Understood? Okay. Do not worry when it is negative, etc. Okay. Do not worry it is negative. It is as simple as the direction indicates the reverse of the motion or the reverse of the frame that you have taken. Okay. As simple as. Clear? Understood this concept. So if you have seen, we have discussed displacement, distance, speed and velocity, and now acceleration. Now we are going to talk about one final concept of, if you've seen the graphs, you've seen the graphs in your 10th and 9th, you know, let's say if this is your graph, okay, let's say you have a motion like this. Let's say this is SNT graph. Okay. Now this is nothing but a parabolic motion. Obviously, therefore, the power is 2. Correct? Because this is parabola. If it's a straight line, let's say if it's this is SNT graph, it's a straight line. You would simply write an equation. Say between these two, you would find the variable. You would find the equation by substituting in your x-axis and y-axis. Okay, you would plot different points when say let's assume my y-axis t, my y is s, correct. So when t is 1, you would get some value. When t is 2, if this is 4. When t is 3, if this is 6. When t is 4, this is 8. You would plot the points 1 2 3 4 and find out the equation between s and t. Okay, for a second let's assume s is nothing but 2. For a second let's assume this is nothing but 2. Okay, this is the relation between these two, and this is how the graph between these two operate. Similarly, because when I'm talking about parabola, it is nothing but the power t square has to be there. For a simple case, let's assume this is nothing but s is nothing but t. Okay, s is nothing but t square. Okay, now if you remember all the slope, that is your ds by dt. ds by dt is nothing but your slope, because at this instant, what is that slope? If I'm asking you to find, I'm asking you to find the slope at this instant, you would draw a tangent. If I'm asking you to find the uh, slope at this instant, you would draw a tangent like this. Okay, tangent in all your concept is nothing but tan theta. Okay, the slope of S and T graph, the slope of ST graph, that is your displacement time graph, gives you velocity. Slope of ST graph gives you velocity. Slope of VT graph gives you acceleration. As simple as that. Okay, because why? If you have seen, velocity is nothing but change in displacement by time. Acceleration is nothing but change in velocity by time. And in for all your slope calculations, if you remember maths in the 10th class, etc., given any graph, let's say this is your graph. Okay, how would you find the slope? It is nothing but this minus this is your slope. Okay, this is the angle that you are going to find out. Difference between these 2 points is what you are going to find out, which is exactly is what your concept that we have applied here. Okay, difference in time, difference in velocities is nothing. Sorry, difference in displacement, will give you velocities, which is the slope. Difference in velocities will give you acceleration, as simple as. Clear? Understood this concept? So tomorrow we will see a couple of problems based on this. So remember this: slope of ST graph will give you v, that is velocity. Slope of VT graph gives you acceleration. Okay, clear on this. Tomorrow we will see a couple of problems. We will see different varieties on average speed, instantaneous speed, etc. and all. We will see all those things, and we will solve further. Okay, fine. Any questions you have, any doubts you have, please do ping me.